Hi, my name is Nur Zahira Nadia binti Zaini and my metric number is BE2030110. The introduction for this project is our task is to use both manual calculation and simulation to analyze and resolve an RLC circuit problems. So our job is to use Fourier series to manually calculate the voltage at each node, the current in each branch, and the power on a single load RLOC. In order to verify correctness and consistency, we must also use MATLAB or a comparable program to simulate the identical circuit and compare the outcome with our hand calculation. So this project is a great chance for us to learn more about linear circuit analysis and use methodical approach to solve practical problem. Next is the manual calculation for this project. This is our circuit, which is consists of 2 ohm and 2 farads. Next is the our graph that we choose. First step is we need to find the piecewise fx from the graph, which is ft 10 t between 0 and 1, while the negative 10 is t is between 1 and 2. Second step is we need to find the n naught, and then we get the n naught is equal to 0, which is this is odd symmetry. Then third step is we need to find the an, and an is equal to 0. And then fourth step is we need to find the omega naught, and then the omega naught is equal to pi. Next step is we need to find the bn. For the bn, we get the answer is 15 per n pi, and then which is n is equal to the odd. And then while the n is even, we get the bn is equal to 0. Next, we get the ft is um infinity. Sum n equal to 1 is odd, 15 per n pi sin n pi t, and then n is equal to 2k minus 1. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nila Natasha binti Muhammad Izam, DE230121. So for the first step, after we calculate N, N naught and Bn, we have to change the circuit from T domain to S domain. So for capacitor, the result will become 2 over S. And then we calculate amplitude. An is equals to square root of An square plus Bn square, with the phase N is equals to negative tan inverse Bn over An. So for Vi1, we get 12.723 with angle of negative 90 degree. Vi3 is equals to 4.244 with angle of negative 90 degree. For Vi5, 2.54 with angle of negative 90 degree. Vi7, 1.81 with angle of negative 90 degree. And then we calculate Zt. Zt is equals to 2 plus 2 over S. And then we change S to J and pi. So we get 2 plus 2 over J and pi. For I, we calculate using Ohm's law, which is I is equals to V over Z. For I1, we got 6.06 with angle of negative 72.34 ampere. For I3, 2.11 with angle of negative 83.94 ampere. For I5, we get 1.27 with angle of negative 86.36 ampere. For I7, 0.90 with angle of negative 87.39 ampere. And then for power, the formula of power is P is equals to VDC IDC plus 1 over 2 Vn In cos theta n minus phase n. So for the first thing, we have to calculate V0 using voltage divider, which is 2 over J0 pi over R plus 2 over J0 pi times Vs. Since Vs is equals to 0, so V0 is equals to 0. So for n equals to 1, for the power is 36.76 watt. For n equals to 3, the power is 4.45 watt. for n equals to 5, the power is 1.61 watt. For n equals to 7, 0.81 watt.
Assalamualaikum. I'm Putri Nisha Damian binti Rosmi, matrix number DE230117. So I'll be explaining regarding the simulation part by using MATLAB on how to gain the AC input signal for RC circuit. So first and foremost, we need to define the circuit parameters, which we have a resistor, 2 ohms, capacitor with 2 farads, and then the period of the signal is 2 second. And then the frequency of the signal, the formula is equals to 1 over T. And next, we need to define the input square wave signal, which V source is equals to 10 volts. It is also equals to the amplitude of the square wave. And then input signal, it is equal to V source times with square 2 pi ft. And then the number of terms in the Fourier series is 2, because we use resistor and the capacitor. And then we need to compute the Fourier series approximation, where we know AN is equals to 0 because of it is the odd symmetry, and BN is equals to V source over T times with traps T input signal times with sine 2 pi n ft. And then as we can see from the picture above is the AC input signal for RC circuit. Alright, moving on to the next simulation part, which is to find the value of AN, BN, and A0, and also to visualize the graph of AN, BN, and A0. So first thing first, we need to define the circuit parameters in order to find the value, and then define the input square wave signal, and state the number of terms in the Fourier series, which is 8, because um, we want the outcome to be in 4 value, and then compute the Fourier series coefficients. So for Bn, how to compute is 2 over t times with input signals times with sine 2 pi n ft. And then since it is an odd symmetry, so A naught, the DC component, is 0, and An, the cosine coefficients, are all 0. And then to visualize the graph, we need to plot the cosine coefficients in AN, and then plot the sine coefficients BN, and plot the DC component A0. And lastly, we need to display odd and sine coefficients. So as we can see from the command window below, we got the value of the BN, B1, B3, B5, and B9, and um, the graph visualized above is the value of the AN, BN, and A0. So to conclude is B, the sign coefficients BN is verified with the manual calculation.
Assalamualaikum, my name is Siti Noatira binti Ruslan and my matric number is DA230119. I will explain the MATLAB coding to get the outcome of current, voltage and power using Fourier series. So first step is define the parameter, which is amplitude is 10 volt, T is 2 second, resistance is 2 ohm, capacitance is 2 farad, and last is omega 2 pi over T. Next, we use the coding to find the V, Z, magnitude, I, and power that shown in this slide. Then we store the result to display the N, current, voltage, and power to get the output. The result of the Fourier series using MATLAB is shown in the command window. To prove that the result for manual calculation and MATLAB simulation are equal. So that's all from our group. Thank you.